أيها الطلاب والطالبات، اليوم درسنا هو في تخطيط القلب الكهربائي المسمى ELECTROCARDIOGRAPHY. Here we need to concentrate about the electro, which meaning electricity. Cardio is the heart. Graphy is the graphic representation of electrical activity of the heart. The ECG is the graphic representation of electrical activity of the heart. So that we have to know about the electricity. Electricity, what is this electricity and how this electricity can be initiated inside the heart? And we have to know about the heart itself and the conductive system and the graphic presentation. Here the electricity of the heart, it's similar. We would like to take a piece from the heart or a single cells from the myocardium. This is a single cells from the myocardium. Single cells from the myocardium, or a piece containing 3 cells. Here look like a battery. It is have a negative and positive poles. The electrical movement is coming from the negative here toward the positive. The positive wave coming toward the positive and initiate the lightning, which similar to the electricity here. This is the cell, and this cell at rest. Inside it is the negative, and outside it is the positive. This positive refer to sodium and calcium in general, and the negative is referred to potassium. At resting state, the resting membrane potential is equal to minus millivolt. This need what? Threshold potential. The threshold potential is about minus 70. When the resting membrane is reaching the threshold potential under the stimulus, external or internal stimulus, that is the sodium, it is enter the cell. When the sodium is enter the cell, the positive charge, it's filled the cell, so that it is increased the action potential. The action potential, it is increased up to 0. This is 0. It is the separation between negative and positive outside. It's become 0. Now it is toward the negative side. So the internal of the cell is become positive. That is means it is depolarizing. The cell, it is depolarizing now. Depolarizing the positive charge inside and the negative charge it's outside. Here the second step, the sodium, it is stop. The channel of the sodium ion is stop, closed, and the potassium is start to go outside here. This is the first step. The second step, it is the entrance of calcium, which is make the plateau phase of action potential. This, the plateau phase of action potential, entrance of calcium, the neutralization between the calcium and potassium, and the third step, in which the potassium is outside, is coming outside, the fast, and then the slow outside the cell, which make a repolarization. How this initiated? The action, this is the action potential. The action potential, it is initiated between the cells. This positive charge is moving to the second cells by gap junction. The gap junctions between the cardiomyocyte. It's the characteristic of cardiomyocyte. When the sodium is disseminated to the or spreading to the another or adjacent neighboring cell, it is initiate the depolarization. And the potassium at the same side, when it is go outside, is come back to the first cell to initiate the threshold potential. This is go back, and this is go interior, the sodium. And then the action potential is spreading as a wave or a vector from the negative side toward the positive side, from negative electroid toward the positive electroid. If we are put here what? Galvanometer. Galvanometer. This is positive and this is negative. The galvanometer, this is neutral. It's moving toward the positive. If the vector, the charge is coming toward the positive electrode, it is for a positive deflection. Here we will go to the heart. We will go to the heart now, and let us to draw the symbol diagram of the heart. Symbol diagram of the heart. This is the right, this is the left atrium, this is the right atrium, this is the left ventricle, this is the right ventricle, and this is the SA node, which located in the upper outer part of the right atrium, and this is the AV node. This is the bundle of Hess and bundle branch, left bundle branch and right bundle branch. Left bundle branch is further divided to anterior vesicle and posterior vesicle. Here it is the Purkinje paper, which arranged the internal myocardium is not extended to external. Internal myocardium, which called here a myocardium, endocardium, myocardium, or epicardium. It's reaching to the endocardium and also to the first layer of myocardium. Here the electricity is coming from the pacemaker. Pacemaker, it's called SA node, which have automaticity, exhibit automaticity. The action potential in the AV node is different than the myocyte. It's like this. There is no step, and this is the action potential in myocyte. Action potential in myocyte, it has fourth step: 0, 1, second, third, and fourth. But the SA node, fourth and 0 and third. There is no 1 and 2 because it is not contractile. This is only for initiation of electricity, automatic. The impulses is spread to all of the atrium and reached to the fibrous band here and stopped because the fibrous band, it's blocked the impulses from going to ventricle. Only through the AV node that's slowing the impulse and to the head of bundle through the bundle branches to the Purkinje fiber, which activate the ventricles at the same time, both ventricle at the same time. After finishing the repolarization is starting from the outside to inside and in this direction, from the positive toward the negative. The repolarization, as we know, it is carry the negative charge. Negative toward negative, it's caused positive wave, is represented by the T wave here. Thank you for your listening.